Alright, good morning. This is part 2, the last 3 questions for electric fields. So here, what force is exerted on a charge of this when it is placed in an electric field of strength 60 newtons per coulomb? So we know we have a field strength E here because it's newtons per coulomb. We know that we have a charge here, so this is a charge. So where you can go is our FQ over Q. So here if we want to solve for force, we can multiply by Q. FQ is Q times E. Here they give us our Q is 5e to the negative 6 coulombs of charge, and our energy or our electric field strength is 60 newtons per coulomb. So our force on this charge is just going to be those two multiplied, which is 5e to the negative 6 times 60. And this is 3e to the negative 4, or what newtons, because it's a force, 0.1234003 newtons. Okay, so for those values, the force that this charge feels is just that tiny force. Number 4, what is the electric field strength at a distance of 0.75 meters away from a 90 microcoulomb charge? So this time we have a distance r and we have a charge q. So this time we can't use this because we won't have E or F. So let's use our other formula that we got. The number 2 that we saw, E is kq over r squared. So AE is kq over r squared. Our k is just a value, is a constant. What's the constant again? It's 8.98 times 10 to the 9. Our q charge is 90 microcoulombs, or 90 times 10 to the negative 6. And then our r is 0.75 squared. When we type all that in, we get 1,438,080 Newton per coulomb. The reason why I put Newton per coulombs is because that's the value of what the electric field strength means. Okay. Last of all, two negatively charged spheres are 30 centimeters apart. What's that? 0.3 meters, because I know I'm going to have to convert that. One has this and the other has that. What is the electric field strength in the exact middle point? So we have a negative charge and a negative charge. One's 1.5 e to the negative 6. One's 3 e to the negative 6. They're 0.3 meters away. So if I put something right there, those are both negative. A positive test charge will want to go towards that one and towards that one, but by how much? So you're going to have to do two separate ones. Find out what this is, find out what that is, and put them together. Okay, so our electric field strength of the first one here is going to be, we have a distance, so we're going to have to use the k one. Kq over r squared. In this instance, it's going to be k times q, which is the charge of your main thing, which is 3e to the negative 6, over r. This time it's from the middle to there, so it's not 0.3, it's going to be 0.15 squared. Okay, and then we're also going to have to do it for the second point here, which is E2, which is kq over r squared. This time it's k times this q. And then our r again is going to be that 0.15. So then our electric field due to the first one is going to be 11,000 or 11 1.198 million newtons per coulomb, and then this one's going to feel a strength of 599,200 newtons per coulomb. So it'll want to go that way by that much and that way by that much. Overall, this number's bigger, so I'm just going to go this minus that, and it'll tell us overall how much it wants to go left. Okay, so we're going to go E1 minus E2 is going to be our electric field in the net direction, which is going to be 11,900, or not 11,000, but that number minus this number. And there's our answer. It'll end up wanting to go this way more because there's more charge pulling it than that way. So that's our answer. Thanks.